Welcome back to Pratik Academy. In last video we have seen Varignon's theorem. In this video we will solve some sample numericals based upon first chapter. So let's start. So before going for actual numericals, let's take down some important formulas. This is the analytical method for finding resultant of two vectors, that is parallelogram law of forces. This law states that if two forces are represented by sides of parallelogram, then diagonal of parallelogram represents its resultant. Here remember that both these two forces are of having same nature, that is either they are moving outward from point or towards point. Okay, according to this we have resultant is equal to under square root p square plus q square plus 2pq cos theta. Then alpha, that is angle made by resultant, is equal to tan inverse of p sin theta upon q cos theta plus p. Remember that this angle is with respect to q force here. Okay, with respect to q force. Then next is here, next is for concurrent force system. We have summation fx is equal to sum of horizontal components of all forces, that is f1x f2x plus f plus dot dot. Okay, plus then summation of fy is equal to f1y plus f2y plus so on. Then here resultant is given by under square root p square px square plus py fy square here. Then then theta, it is angle made by this resultant with respect to horizontal, is given by tan inverse of summation fy upon summation fx. Then next, for non-concurrent force system we have summation fx summation fy similar to concurrent, but here adding moment term, that is moment of resultant force about any point A is equal to summation of moments of all the forces about point A. Then here for calculation we are assuming sign convention. For force, if force is moving towards right side, then we are assuming it is positive. If force is towards left side, then we are taking it as a negative. If force is downward, then negative. Force is upward moving, then it is positive. Next sign convention is for moment. If moment about a point tries to rotate the body clockwise, then it is positive. If it is trying to rotate body in anti-clockwise direction, then we will treat this as a negative. Okay, so these are about formulas and sign convention. So let's solve first numerical. So this is very simple numerical and it is based upon parallelogram law of forces. Here statement is two forces 100 kilonewton and 200 kilonewton are acting at a particle with 40-degree angle between them. Find resultant force and its direction. Here P 100 kilonewton, Q 200 kilonewton, theta is given 40-degree, and they have asked what is R and what is alpha. Then here this problem can be solved by using parallelogram law of forces. Here value of Q is 200 kilonewton, value of P is 100 kilonewton, theta is given and alpha is asked. So first resultant is equal to under square root p square plus q square plus 2pq cos theta. Here theta is given, q is given, p is given, also q is given, p is given. So we can easily calculate value of R, and it is coming 283.97 kilonewton. The next is the inclination or angle made by resultant with forces. Alpha is equal to tan inverse p sin theta upon p cos theta plus q. Here theta is known, P is known and Q is known, so we can calculate easily alpha, and it is coming 13.08 degree, and it is with respect to 200 kilonewton. If we want to calculate this theta with respect to force P, then just subtract this angle from 40 degree. So 40 degree minus this 13.8 is coming 26.91 degree, and this is with respect to 100 kilonewton force. Now consider next problem. Statement is solve following problem analytically. They have given force diagram. There are total 4 forces are acting here. 20 kilonewton making angle 30 degree with vertical. This horizontal force is moving along x-axis and towards right, 10 kilonewton force. Then 30 kilonewton force is moving upward and it is along y-axis. 25 kilonewton force making 150 degree angle in clockwise sense with respect to positive x-axis. Okay. Now first step is to resolve all the forces in x and y direction and consider sign conventions. Sign conventions, as we have discussed: positive force, so upward force positive, downward force negative, right side force positive, and towards left side negative. Okay, this is our sign convention. So for first force, this 10 kilonewton, it is moving, it is along horizontal, so it is having only x component, and it is moving in right direction, so it is a positive. Okay, and for first force, y component is 0. Now consider second component, second force, this 20 newton 20 kilonewton force. This force making 30 degree angle with vertical. Okay, then resolve this force into components. So this force can be resolved into components by this way: one force downward direction, one force rightward direction. So F2x is equal to this opposite side of 30 degree. So F2 sin 30, F2x will be here F2 sin 30. Then by putting values, it is coming 10 kilonewton, and it is as moving in rightward direction, it is treated as a positive. Then vertical component, it is F2y, it is moving in downward direction, and this is adjacent side of 30 degree angle. So F2y is equal to F2 cos 30, and this value is coming 17.32, and it is moving in downward direction, so negative. Then next force is this 25 kilonewton force. This total angle is 150 degree, out of which this quadrantal angle is 90 degree, so remaining angle will be 60 degree. So consider only that part and resolve this force. So two components, F3y moving downward direction, F3x moving towards left. So F3x is by opposite side, F3 sin 60, and it is coming 21.65, and it is coming negative because it is moving towards left side direction. Then next is F3y. F3y is equal to F3 cos 60, and it is coming 12.5, and it is in downward direction, so negative. Then last force is this 30 kilonewton. It is moving in upward direction, and it is having only vertical component, no horizontal component. So F4x will be 0 here, and F4y is equal to 30 kilonewton and positive. Now add all fx. So all fx is equal to F1x, F2x, F3x, F4x. By adding all, we get resultant x component as minus 1.6 kilonewton. Similarly, if we add all vertical components, resultant y component will be 0.18 kilonewton. Then resultant force is equal to under square root resultant x component square plus resultant's y component square, and it is coming 1.61 kilonewton. So this is resultant force. Now to find out, it is important to find out inclination and direction of resultant. Here our x component is negative, so this will be along x direction but in towards left side. Y component is positive, so it is in upward direction, so its resultant is lies in this plane. Okay, this plane means third plane or third quadrant, sorry, second quadrant here. And to find out theta, theta is equal to tan inverse of fy upon fx. So fy is given, fx is known, so value is coming 6.41 degree. So in this manner we have calculated resultant force and its inclination with respect to vertical. Then next problem. So this is again important problem. Statement is 3 concurrent force systems is as below. 40 kN force is along x-axis, 40 Newton force making angle alpha with negative y-axis, and it is measuring anti-clockwise. Then for 80 kN force making angle alpha with again negative x-axis here and measuring clockwise, and they have asked find the angle alpha and magnitude of resultant if its horizontal component is 0. Okay, so from given description we can draw figure. 40 kN is along x-axis, so first 40 kN force is drawn here, drawn along x-axis, and it is towards positive direction, that is moving in right direction. Then second 40 kN force making angle alpha with negative y-axis, so this is positive y-axis, negative y-axis making angle alpha in anti-clockwise sense, that is in this sense. Okay, so this angle is alpha here. Then next is 80 kN making angle alpha with again negative x-axis but measuring in clockwise. So this is positive x-axis, negative x-axis, and angle is measured clockwise. So this angle is here, sorry, again it is here anti-clockwise, so again anti-clockwise sense, and here there is a correction, so take this as a anti-clockwise. So again anti-clockwise means in downward direction with negative x-axis. Okay, now to solve problem, here in this problem we have to find out alpha and r. Okay, so from figure we can conclude that this angle is alpha, this angle is given again alpha, so this angle between these two forces must be 90 degree. Okay, that is angle between 80 Newton and 40 Newton must be 90 degree. Then first find out its resultant and resultant of these two forces and its inclination. So this is according to our parallelogram law of forces. So R1 is equal to P2 square plus P3 square plus 2P2 P3 cos theta 1. Here theta is 90 degree, so cos 90 will be 0. So R1 is coming 89.44 Newton. Then resultant of this, if we consider P3 as a Q, then tan inverse of P2 sin theta 1 plus P2 cos theta 1 plus P3. Again theta 1 is 90 degree, P2 is known, P3 is known, So alpha 1 can be easily calculated, and it is coming 26.57 degree. Okay, so the resultant of these two forces is lies along this direction. Okay, making angle here 26.57 with respect to force P3. Okay, now as horizontal component of resultant is 0, so summation fx will be 0. Now here we have calculated resultant of these two forces, so not required to consider these forces again here. So summation fx means 40 Newton positive sense. Okay, then this resultant value is 89.44 and making total angle of alpha plus 26.57 degree with x-axis. So 40 minus 89.44 cos of 26.57 plus alpha is equal to 0. By solving this equation we easily get value of alpha. Now as resultant having horizontal component 0, so vertical component is equals to its value. So resultant summation of fy is equal to resultant force, and here y component, so 89.44 sine of 26.57, and this angle is we have just calculated 36.86, so mention here, and r is coming minus 79.994 Newton. Minus sign indicates force is in resultant force is in downward direction. So in this video we have solved some simple numericals on parallelogram law of forces and concurrent force system. If you like this video, please share this video with your friends, comment on this video. Thank you for watching.